They crashed a US missile into the Zone of Silence. The radio dies mid-sentence. A compass needle jitters, then swings as if chased. In the headset, a countdown voice cracks, fades, returns as a whisper. On a clear night above northern Mexico, a US Athena missile strays from its line and disappears into desert. They'll say the air ate the signal. They'll say clocks ran wrong and the sky dropped stones. They'll call it the Zone of Silence. To understand why a rocket crash rewired a landscape in the legend, we rewind to the test range, the control room, and a patch of ground that already made instruments nervous. The crash that named the desert. On paper, the 1970 Athena test was routine. White sands of the Gulf, an arc that engineers had drawn and flown before. The guidance stack rolled inside, gyros humming, accelerometers attentive, a radio link ready for mid-course corrections. On the console, the track started clean. A tiny light pulsed on the plot board, nominal. Then the wind aloft bit harder than forecast. Guidance compensated, but not perfectly. A small error is just that for a heartbeat. But an Athena doesn't stroll, it sprints. At speed, a degree means miles. Controllers watch numbers creep. A radar return lagged where it shouldn't. The telemetry stream hiccuped. It came back, carrying noise that didn't mean much. Heart rates rose. The room got quieter as people stopped narrating and started listening. Range safety didn't see an immediate reason to terminate. The window for a correction narrowed with every second of combustion. Out over the borderlands, the missile began to drift southeast of plan. The words sounded sterile, off nominal trajectory, but the visual, if you were on the ground, was anything but. Bright lands crossing a sky that usually keeps its own counsel. A tail like a cutting torch dragged across the stars. Telemetry vanished. The tone that meant we still have her went flat. The consoles kept their glow. People leaned closer, waiting for a packet, a checksum, a single valid line. Nothing arrived. A breath held across the room had nowhere to go. They marked it lost. Across the desert, a rancher saw the sky change color. The air trembled before sound reached him. He thought of storms. Then the flame bent and fell, and the night bloomed white. A second later came a pressure you felt in your ribs. He counted because that's what his father had done in thunderstorms. He lost count. The echo got in the way. Miles away, a prospector walking between low ridges heard stones ping as if rain had turned to iron. He dropped flat. The flare sank behind a dune and the horizon pulsed. In his mouth, dust tasted metallic. The trajectory projections, now hypothetical, drew a fan into Mexico's Chihuahuan Desert. Someone said the word recovery, and someone else said clearance. Lines to Mexico City opened. A joint operation formed in hours. The vehicle had carried no warhead. The politics would be sensitive anyway. A U.S. missile had just buried itself in another country's sand. You don't wait for daylight to start explaining that. You also don't sleep well until you know where it is. Convoys rolled south. Trucks that normally carried drilling rigs now carried men in hard hats and men in uniforms. Helicopters thudded low, chasing heat signatures that had already cooled. They flew by lights on the ground, ranch compounds, highway gas stations, and by the older beacons you can't see, arroyos, pale flats, dark mesas. Locals met them with curiosity that wasn't friendly or hostile so much as practiced. In this desert, visitors arrive when someone needs water, or someone finds or something falls from the sky. The men asked for directions and got opinions. It went toward the salt, one said. Toward the hills, another said. Someone offered coffee. Someone sold fuel from barrels. Word spread faster than official notices could catch it. The impact site was not a neat crater. The Athena had broken low, shedding parts across a scatter that looked like a meteorite-strewn field. Fitting, people would later say, though the cause this time was human. The main body gouged a trough where the ground gave way. The sand smelled scorched, a tumble of alloy ribs, charred insulation, clean-angle fragments that didn't look like anything natural. Heat lingered in places you couldn't see. By afternoon, the perimeter went up. Tape first, then a ring of trucks, then men with radios who checked badges that most bystanders didn't possess. A mobile light tower arrived and turned night into a pale morning that robbed the stars of any authority. That's when the stories started congealing. Men in suits, some said. Instruments that made clicking noises no one recognized. A tent where they carried something heavy and didn't let it touch the ground. A few faces at the tape looked the way people look at storms, worried, thrilled, and ready to tell it later. What actually arrived were field geologists with magnetometers, flight safety officers copying serial numbers onto forms with carbon paper, and technicians trained to pick up parts without leaving fingerprints of sand. The magnetometers were standard kit for metal search. In a place like this, they also noticed more than debris. Needles twitched near the scrub. A reading would jump, settle, and jump again a few paces away. Someone laughed and said the ground had opinions. Meanwhile, a rumor outran the convoy that radios died in the area and compasses spun. Some of the radios did misbehave, mostly handhelds in low spots where line of sight meant nothing. Some compasses did jerk, especially the cheaper ones, near patches of rock with iron that would have been mined if the desert had roads good enough. In retelling, sometimes became always and jerk became spun. Curiosity beat caution. People leaned into the strangeness because it made the night make sense. Cleanup under floodlights has its own rhythm. Teams grit a field, bag parts, log coordinates, and move to the next square. Mexico's officials stayed close, asking the questions you ask when a foreign rocket makes your desert sound like thunder. The answers were terse and careful. No payload of concern. Guidance failure under investigation. All materials to be removed or buried safely. The last promise hung in the air. What does it mean to bury safely? How deep makes a story disappear? They dug pits for pieces that could be rendered harmless by depth and loaded trucks with what had to go back to the lab. Scorched sand clumped under boots and stuck to the soles like memory. The guarded perimeter tightened. Someone brought in a bulldozer. Its engine note filled the basin and made conversation an effort. The light tower hummed and drew a halo of moss that must have thought sunrise had moved. Outside the tape, a teenager from a nearby village kept a notebook. He wrote what people said. The next day, he had walked to a town with a newspaper and offered a story for a few pesos. Zona del Silencio, he wrote, because he heard an engineer joke that he couldn't get a station on his radio. The name fit like a coin in a slot. Everyone could feel what it promised. A place where the modern world's voice goes thin and where your own imagination gets loud. The phrase traveled. Reporters liked the contrast, silence that made headlines. They reached for older stories, times when watches stopped and when a man's donkey balked and refused to cross a dry wash because some animal sense told it the ground ahead behaved wrong. They braided those tales with the new images, U.S. trucks, floodlights, the smell of burned fuel. Secrecy did the rest. Not conspiracy, standard operating procedure. But pack enough procedures into one dry basin and it reads like a cover-up. No one stood on a roof and announced, "We lost track because the wind tilted us some small errors and then our signals hit the wrong geometry." They said as much privately. Publicly, the silence held. By the time the last bag was sealed, the last piece of alloy tucked under a tarp, the name had married the place. Zona del Silencio. A label that took an accident and retrofitted it onto a landscape that had been odd long before. You could feel the new gravity of it. Travelers started stopping on highways to stare into the empty and tell each other what happened here. Vendors sold sodas colder than the night and pointed toward the flats as if they were pointing to a secret. To see why the crash mattered, we need the land beneath it, the basin that gathers iron, the flats that drink salt, the rock that remembers where it cooled. Only then does a missile's lost voice make sense against a desert that was already muffling certain sounds. The desert that bends needles. Draw the map by emptiness first. North of the boson de Mapimí, where Chihuahua, Coahuila, and Durango nearly shake hands, the land sinks into a shallow bowl of dust. Ranges stand back like quiet spectators, low basalt caps, eroded volcanic necks, chalky limestones that crumble under a boot. In the center, pale flats flash in the sun, salt pans that remember vanished lakes. Arroyos cut fans across the floor and then disappear as if their water lost interest. Under that quiet surface lies a basement patched together over time. Ancient marine sediments packed with iron-rich sands, volcanic ash beds altered by heat and fluids, lenses of magnetite mixed into conglomerates like pepper and dough. In places, basaltic dikes thread through the older rock and carry iron minerals that took a magnetic set when they cooled. The desert didn't choose magnetism, it accrued it. People who work this ground treat the compass with respect and caution. A bearing you take at a ridge can drift by 10 degrees a few hundred meters later, then snap back as if the landscape sighed. The needle doesn't whirl like a horror story. It hesitates, tugs, and settles where local minerals tug harder than the planet does. Surveyors talk about declination and call it a day. Here, they add local attraction and keep walking. Field accounts stack up like small cairns. A ranch hand checks his route to a well and notices north isn't where it was yesterday. A geologist records a magnetic azimuth to a contact, moves 20 paces, and writes a different number with the same instrument. A road crew tries to keep a straight line across a playa, and later discovers their path curled subtly toward a darker streak of ground that, when dug, stains the shovel red, black. None of it proves a grand anomaly. It proves noisy ground. Radios complicate the picture because they tie the desert to distant voices. One day, a VHF handheld sings clear to a partner on a rise 2 kilometers away. The next, the same pair finds only static when they drop into a wash. UHF links bounce off a mesa and arrive strong in a place you didn't expect. HF skips change at dusk. The ionosphere lowers its mirror and suddenly a station in Sonora overpowers the one in town. People say the air eats the signal. The air mostly follows rules, but the ground participates. Look at the salt. The flats at Mapimí glint because halite and gypsum sit near the surface. Salts draw moisture even in a dry world, turning the skin of soil into a better conductor on some days than others. Radio waves that hug the surface bleed into that conductivity, losses stack. Move a few meters off the pale crust on the caliche and brush, and the radio that was dumb a minute ago wakes up. It feels like superstition until you check a soil map. Meanwhile, the basalt caps and iron-rich gravels don't just carry magnetism, they shape it. Induced magnetization, the rock acting like a weak bar magnet in Earth's field, adds a small local vector. Remnant magnetization, the magnetism frozen in when lava cooled or iron cement formed, adds another, sometimes stronger, sometimes skewed. Add them to Earth's main field and you get a patchwork of gentle pushes on a compass needle. Most of the time, you barely notice. When you're tired, lost, or your gear is cheap, you notice too much. Folklore grows fast in thin populations. A prospector complains that his needle spun, and the bar retelling becomes a whirligig in the next village. A tourist AM radio goes quiet for 3 minutes near a dune, then resumes with a burst of music. By the time it's on a blog, the zone becomes a dome where nothing electronic works. But measurement tells a narrower story. Geological surveys pick up low-amplitude magnetic anomalies the way a sensitive microphone picks up room tone. Distinct, yes. Planet breaking, no. A hydrologist working the basin jokes that the map looks like a spilled box of dark crayons, streaks where former channels carried ironstone pebbles and then stopped. On those streaks, handheld magnetometers chirp more. Flux gate sensors draw small wiggles and compasses bias toward the line. Step off it, and the signal relaxes. The desert lays down clues, not commandments. Then there's the angle of the sky. Mesas and low Sierras aren't high, but they're enough to mask line of sight for VHF and UHF. Walk behind a shoulder of rock and your partner's voice goes mushy. Climb 3 meters and it snaps clear. HF plays by different rules. At midday, the skip is lousy, and you feel alone even at 10 watts. At night, the band opens and you're suddenly in company with strangers hundreds of kilometers away, while the next arroyo over remains deaf. It doesn't help that time feels strange when you're heat stressed. Watch batteries die faster in temperature extremes. LCD displays wash out. A quartz oscillator that's supposed to hold a steady beat can drift when heated. A rancher swears his watch lost 5 minutes near the flats. Years later, a student repeats the walk with a fresh Casio and records nothing unusual. The brain keeps both stories, but the stranger one sticks. So why does the needle bend here more than in the next basin over? Because this bowl gathered what was available. Iron-rich sediments settle where the lake once stood. Later, volcanic episodes vented ash and basalt that cooled with a magnetic stance. Fluids moved through fractures and left magnetite and hematite behind in veins and lenses. Wind sorted grains by weight and shape, dragging lighter sand away and letting heavier, darker grains lag behind in swales. Over time, you get patches with enough magnetic personality to nudge. Notably, the anomalies are patchy. Walk a kilometer and you'll traverse quiet ground and lively ground, sometimes without a visual cue. That's why compasses misbehave in a way that's hard to map without dense measurement. Aviation charts won't mark it. The effect isn't strong enough at altitude to matter to modern instruments that average vectors and self-correct. On the ground, with a simple needle, you're living in the texture. Locals develop their own corrections. Use distant range lines, not the needle, for long bearings. Carry 2 compasses. Trust neither when they disagree, but trust the landscape you know, where a certain thorn tree leans, where a rock darkens after a dusting of rain. People say time slows here. What they mean is that you stop relying on gadgets and start watching shadows. Myth presses on measurement at the edges. Articles promise a triangle of silence as if the borders were surveyed. In reality, the zone is a cultural overlay on a geologic quilt. One day, a visiting crew drives in with drone gear and gets perfect telemetry. The next, a radio mic cuts out during an interview, and off camera, everybody smiles because the story just paid a dividend. The truth lives in the in-between, instruments that hiccup, directions that drift, and a desert that rewards attention. Strange ground is one thing, strange skies are another. People here talk about stones that seem to prefer this basin, iron hearts half buried after slow rains. They point to collections in town and the pitted faces of weights on a scale. To test whether the heavens actually favor this place, we have to look up, then down again at how deserts fake patterns and how rocks from space tell their own. Stones from space keep finding this place. Before the missile, the sky had already been busy here. Ranchers told of nights that bloomed green, then fizzled into cinders that left a smell like hot iron. Kids grew up knowing a word for heavy rocks that fooled magnets and shattered knives, aerolitos. In town, a shop window kept a tray of pitted dark fragments that looked like burned bread crust. People called them gifts. Scientists called them iron meteorites. There's a parallel down south at Campo del Cielo in Argentina, a strewn field famous for iron masses scattered across plains. The comparison isn't perfect, but it gave locals and visiting collectors a frame. An open landscape, sparse vegetation, heavy stones that survive weather, stories that last. The Mapimí Basin doesn't host a single legendary fall with a name stamped into textbooks, but it has something else, accumulations that feel like the desert has a magnet in its pocket. The first trick is preservation. Deserts cheat the calendar for iron. Where forests and rain quickly oxidize and bury, arid ground slows the rust and keeps shapes clean. Wind peels off lighter sand and leaves lag gravels, dense scraps that include iron fragments. Over decades, the lighter matrix lifts away grain by grain. The heavier pieces concentrate like coins at the bottom of a stirred jar. Walk a wash after a blow and you'll find in the elbow of a bend a cluster of black stones with a metallic glint under dust. Back them with a magnet and they click softly, one by one. Documented falls are rare events anywhere. Dense finds tell a different truth, where the ground lets you see what the sky already gave. A single fall can seed a field with fragments that are rolled out for generations, making a basin feel active long after the event. Add in unrelated small irons dropped over centuries, and the impression thickens. The zone's reputation grows because people can find, not necessarily because the heavens deliver here more often. Still, the rocks themselves change how instruments behave. Iron meteorites are magnetic, not just because they're iron, but because their structure, camosite and taenite intergrowths that take and hold magnetization. A detector meant for coins complains loudly over a fist-sized octahedrite. A handheld magnetometer logs a spike. A simple magnet on a string swings in a way that feels like a yes/no answer from the dirt. Hunters learn to read that language. The field becomes a slow conversation with beeps and pauses. Meteorite collections in northern Mexico are patchwork archives of this conversation. In Mapimí and Gomez Palacio, private drawers hold fist-sized irons with thumbprint regmaglyphs and smooth edges from windwork. Each piece has a provenance that's part memory, part map, found near the wash after the second fence, half a day west of the salt under a thorn, where the road bends around a low hill. Labels aren't Latin and catalog numbers, they're the geography of chores and grazing. Scientists step into this with method, densities, magnetic susceptibility, nickel content. An iron that snags a magnet feels eager, but susceptibility measurements quantify that feeling. It also explains a persistent human error. Not every dark, heavy piece is a meteorite. Magnetite concretions, slag left from historical smelting, hematite nodules, all of them can fool the eye. The zone geology increases false positives by offering plenty of magnetic rock that never saw the sky. Series collectors carry a streak plate in a file. A true iron meteorite won't make a red streak, and the interior reveals metallic sheen with nickel tests turning dimly positive. If you lay a grid across the basin and plot finds, you get clusters. Humans draw circles around clusters and talk about attraction, but zoom out and those clusters often match where people actually searched. Along tracks, near ranches, on accessible flats. We see pattern where effort went. This is searcher bias, not magic. It doesn't kill the romance, it gives it edges. When a new road cuts across a quiet patch, vines sprout along its shoulders. The sky didn't change. Our shoes did. There's also the physics of arrival. Earth's atmosphere tears most meteoroids apart. Iron masses resist that breakup better than stony ones, which means more irons reach the ground in solid pieces large enough to find and large enough to generate stories. Their fall geometry produces strewn fields, an elongated ellipse with larger masses near the end. If the wind on the fall night pushed debris, the ellipse stretches or bends. Over time, erosion moves fragments downslope into arroyos and out onto playas, re-tilting the field in slow motion. The modern distribution is both a record of a fall and a record of 1,000 rains. Get this. Hunters tell of a particular tone in their detectors, a broader, heavier sound than junk wire or spent cartridges. They call it the bell. One man followed that bell to a piece barely visible to caliche, a palm-sized iron he pried loose with a screwdriver, and a patience born of afternoons. Another followed it to a rusting bolt. The bell isn't mystical. It's the metal's response spread across frequencies, but it's personal enough to feel like luck. The magnet narrative tightens around these finds because the zone soil already tests magnets in subtle ways. Lay an iron meteorite on a patch of magnetically noisy gravel and your compass barely budges. Set it on a slab of quiet caliche and the needle quivers enough to notice. People stack these moments into a story. The land pulls the sky's iron in, the iron then pulls the needle. It's a neat loop. Too neat for strict science, but tidy enough to travel. Some claims stretch beyond what measurements can carry. Charts circulate with a tidy triangle drawn between towns, promising a hot spot of falls. The triangles in the air are inventions. The ground doesn't honor those lines. Better to talk in gradients, high likelihood where preservation is kinder, where eyes look, where tools beep, where iron stays near the surface. Out past the triangle, in equally dry basins, finds are sparser because fewer feet go there. The desert keeps secrets from those who don't ask. Meanwhile, museums tell a parallel truth. A labeled iron from Chihuahua in a university case might actually hail from a century-old trade, its origin vague beyond northern Mexico. Provenance gets blurry when pieces move through hands that prize weight and feel over coordinates. That blur feeds myths about constant bombardment. The more careful the catalog, the less dramatic the pattern looks. Still special, just not exclusive. Yet stand in that basin at dusk with a detector cooling in your hand and the sky going violet, and it's easy to see why the story persists. Planes of air thousands of kilometers wide carry dust that glows, and every so often, something more substantial arrives. The ground accepts it without ceremony. Sometimes a rancher's plow finds it. Sometimes a kid with a magnet does. Always, the weight in the palm shocks you a little. This came from beyond. Missiles, magnets, meteorites, tie them together and you get a myth that sells. Untie them, and what's left still invites. A landscape that preserves iron, a culture that notices, and a science that can name what fell. Radio's dying is the heart of the legend, though. If stones from space lure us down, it's the silence that makes us listen. Time to test the air. When radios go quiet, start with the basics. Radios don't all speak the same language. HF rides the sky. VHF and UHF ride straight lines. In the zone, each band meets the desert on different terms. A rancher's AM set, down to kilohertz, will sometimes carry a voice from a city he's never seen because the ionosphere decides to act like a mirror. But the ham mic a kilometer away, sitting on VHF, cuts out as soon as he dips behind a low hill. It's not magic. its geometry, and a sky that changes character with the sun. In the middle of the day, the ionosphere's D layer thickens and behaves like a sponge for lower HF. Signals that might soar at night get chewed up by absorption. At dusk, that sponge thins, the higher layers take over, and skip returns. Suddenly, the air is crowded with far voices and the local station drowns. On the ground, it feels like the desert flipped the switch. You mark the time, and later, a story grows legs. The zone kills the radios at sunset. What it really did was let the bigger sky into the conversation. VHF and UHF should be simpler, point line of sight and talk. But a basin isn't a clean room. Mesas and even modest dunes throw shadows made of silence. Stand with your back to a flat-topped hill and call. Your partner on the far side hears a whisper or nothing at all. Climb a few meters and the line clears. A truck roof or a fence post can become an antenna that saves the day. Move again and a notch in the slope steals your link like a pickpocket. You learn to read land as if it were a map of coverage. Then there's the ground itself, not just as surface but as a circuit. Saline flats don't only shine, they conduct. Radio waves near the ground bleed into that conductive skin and pay a tax in power. On some mornings, when dew slicks the salt, the tax rate rises. A handheld that was fine on scrubby caliche becomes dumb on the playa. Drag your boots 15 paces to brush in a little slope, and the signal returns. People say the zone chooses good and bad moods. From a transmitter's perspective, the ground changed impedance while nobody was looking. Add multipath to the mix. Flats and hardpan reflect. You get a direct signal and a delayed twin from the surface, both arriving at your receiver. If they're out of phase just right, they cancel. The radio lies and says no service. Shuffle a meter sideways and the phase relationship changes, the voice snaps back. Engineers call it fading. On a long walk with a tired crew, it reads like mischief. Field tests in the basin turn up patterns, but never a single switch labeled off. A ham operator logs his walk, UHF handheld at half A. What works fine ridge to ridge, dies and washes, returns at the first break in the slope. VHF at 5 watts punches farther, but the same shadows apply. HF at 40 meters is moody. Midday short range is poor. After dark, the band blooms and carries in the people who know the names of towns he's never heard. Shortwave sets and ranch houses act like weather vanes for the ionosphere. Some nights, Havana lands on the kitchen table. Other nights, silence tastes like dust. Claims about total silence don't survive a day of testing with spread-out gear. Even within the same band, antennas matter. A rubber duck on a handheld is a compromise. A quarter-wave whip, held high, changes everything. A simple ground plane with 3 wires tossed on the crust gives the signal a better reference than a sweaty palm. The desert rewards small improvements. Folklore tends to compress all this into one sentence. Nothing works there. The notebook says otherwise. Some things work here, some there, and why lives in the dirt and the sky. That contrast, myth versus measure, keeps viewers leaning in for the reveal. Ionospheric ducting gets a cameo on rare days. Temperature inversions in the lower atmosphere can trap VHF and UHF signals and guide them along like a hose, extending range way beyond the usual line of sight. A crew in the basin hears a repeater from far over the horizon and thinks the zone suddenly favors them. The inversion breaks and the ghost station vanishes. To a human ear that once narrative, the land whispered and then fell silent. The physics flipped a layer. Conductivity changes with season, too. After a rain, the playa isn't a mirror, it's a damp sheet that soaks RF more readily. Weeks later, it bakes back to a brittle crust that reflects better. Meanwhile, mineralized soils shoulder the work. Magnetite grains in the ground don't just tug on compasses, they raise magnetic loss at certain frequencies by tiny amounts. Individually, that's trivial. Across kilometers, those tiny amounts stack in routes you can't see. A walkie that fails along one swell chats easily along another. The zone moved, someone jokes. The zone didn't, the path you chose did. Even the hardware brings its own ghosts. Cheap receivers get desensitized by strong out-of-band signals, a nearby FM tower, a spur from an aging generator intermod from too strong. Stations mixing in the front end. In a quiet place, a small spurious tone becomes an ogre. In a noisy place, it hides in the crowd. A documentary crew blames the zone when their wireless mics crackle. Later, an engineer finds 2 packs run adjacent channels beating each other up. The lesson is dull and dependable. Environment, equipment, and operator all sit at the table. Walkouts with students turn into experiments. They set waypoints and try different bands at each HF for skybounds, VHF, UHF for sightlines. They log signal strength, note terrain, sketch soil types from a pocket guide. Patterns emerge like faint tracks. Washed bottoms are bad. Low saddles are better than knife-edge ridges. Salt crusts are worse than brushy bajadas. Late afternoon saves HF. Mid-morning punishes it. Nothing on the page calls for legends. Everything asks for patience. And yet, the sensation of silence is real. Out here, the human net thins. Cell towers sit far away. Repeater coverage has holes. The first time your radio dies and no car hums on a road and the wind holds its breath, it feels like the world turned its face. Your chest tightens because you've been trained to live inside a constant hum. The zone exploits that training. It doesn't need to kill signals. It needs only to remove the background you forgot you relied on. Compasses misbehave, radios go quiet, both hint toward the same culprit, a landscape that turns physics into texture. Not a dome that forbids technology, but a quilt that forces it to adapt. Which raises a question that rides a legend's backbone. If the ground can scramble a needle and the air can swallow a call, could magnetism in the dirt bend something bigger, something faster, off course? The magnetic skeleton on the foot. To answer that, we have to take the ground apart and listen to what it holds. The Chihuahuan Desert doesn't look magnetic, but its bones are loaded with minerals that remember the planet's field and react to it. Two minerals matter most here, magnetite and hematite. They form when iron-rich fluids move through rock, when volcanic ash alters under heat, or when basalt cools and sits like a record pressed with a groove. Magnetite is the louder of the two, strongly ferromagnetic, while hematite can carry a quieter signal that still counts. Think about how they get concentrated. Imagine an old lake bottom drying into flats, fed by streams that carried sand with iron oxides. Over time, water leached and redeposited iron, gluing grains into concretions and veins. Later, a thin basalt flow crept over part of that surface, cooling through the Curie temperature and locking in the direction of Earth's magnetic field from that day in deep time. Then, weather stripped most of the soft stuff away and left lag gravels peppered with dark, heavy grains. The result isn't a single magnet, it's a patchwork quilt of weak ones. Those weak magnets matter because of two flavors of magnetization. There's induced magnetization. Put any rock with magnetic susceptibility inside Earth's field and it picks up a small temporary magnetization aligned with the field. Then there's remnant magnetization, a semi-permanent magnetization that records some earlier field when iron minerals formed or cooled. In volcanic rocks, that remnants can be strong and pointed in old directions. In iron-cemented sediments, it can be subtler but still present. Add induce and remnant together and you get local vectors nudging your needle. Now climb from concept to experience. A pocket compass is a simple vector averager. It aligns with the net field where you stand, Earth plus local noise. If the local contribution is a few hundred nanoteslas in a certain direction, and the gradient, the rate of change over distance, is steep, the needle will bias and then a few steps later, relax or swing the other way. The famous spin stories often come from walking across sharp gradients with a cheap, damp needle that overshoots. Good compasses still drift in patches like these, but less dramatically. Gradients are the trickster. Instruments that integrate over space, like airborne magnetometers, smooth out the noise. Instruments that sample one spot, like your compass, fill the wiggle room. Put a low-quality digital magnetometer near a pile of magnetite gravel and the display jitters. Put a high-quality flux gate on a mass and you get cleaner curves that result to bumps. The physics stays the same. Our tools decide how messy it looks. Hematite complicates the picture. It's less magnetic than magnetite, but it can carry remnant magnetization and it stains the landscape red-brown. Prospectors trust color as a proxy for iron, and they're often right. Hematitic zones can coincide with magnetic changes because iron moved through those rocks, even if magnetite does most of the compass bending. And coarse samples pulled from nearby ranges. Thin lamina rich in magnetite light up instruments. Hematitic beds sit beside them like quiet witnesses. Then, there's a rumor about uranium. In the mid-20th century, geologists scouted northern Mexico for uranium-bearing formations, and traces do occur in volcanic tuffs and some sandstones. A Geiger counter will chatter slightly higher than background in spots, especially where heavy minerals concentrated. But higher than background doesn't mean hazardous, and it doesn't mean the ground throws off enough ionizing radiation to fry electronics. The numbers locals share, hot rocks, usually reflect natural potassium, thorium, and uranium in trace amounts. Enough to tick, not to terrify. Which brings us to magnetic anomalies as geophysicists define them. Picture Earth's main field as the score, anomalies as improvisations layered on top. A survey would map total field intensity and subtract a smooth model to reveal anomalies, bumps, and dips that trace changes in magnetization beneath. In this basin, you'd expect low-amplitude, short-wavelength anomalies over basalt dikes, iron-rich gravels, and magnetite-bearing lenses. The gradients at the surface might be steep over a meter or two, but the absolute magnitude of the anomalies remains small compared to the planet's field. Small, however, is relative to the question you're asking. A compass cares about direction more than absolute size. An avionics system cares about stability across time and space. An inertial navigation unit locked inside a missile doesn't care much about the magnetic field at all. It cares about accelerations and rotations. Modern systems include magnetometers for attitude or heading aiding, but they weight them lightly compared to gyros and accelerometers, especially when flying through unknown magnetic terrain. Even in the 1970s, the Athena's guidance stack leaned on inertia and radar tracking from the ground, not on a compass in the nose. Still, gradients can scramble bearings for people and for cheap sensors. Survey crews taught the lesson the hard way: don't trust a single compass line through ground with iron. Use backsights, average bearings, and check against the sun or stars. Handheld metal detectors squeal in bands of hot sand because magnetite drives up magnetic permeability and eddy current losses, changing the coil's behavior. That's not interference in the sci-fi sense, it's the coil telling you the medium changed. Scale matters. A handheld compass sees centimeters to meters of rock. A car's dashboard compass averages over the sensor's footprint and the vehicle's steel frame. An aircraft's magnetometer, mounted far from fuselage metal, sees tens of meters and its software filters noise. A missile's inertial platform sees none of this directly. The closer you are to the ground, the more the magnetic quilt tugs at you. The higher and faster you go, the more the quilt blurs into a texture you can ignore. Avionics designers know this. They place magnetometers away from current-carrying wires and ferrous masses. They calibrate for soft iron and hard iron effects, the distortions caused by materials that either magnetize with the field or carry their own. They fuse data. Gyros provide short-term stability. Accelerometers correct drift with gravity. GPS, when available, locks position. Radar altimeters nail altitude. Magnetic heading helps only when it's trustworthy. In a desert with patchy anomalies, the software trusts the magnetometer less. On foot, though, you feel the skeleton. A magnetometer transect across a Bajado will trace little hills of signal, where magnetite lag gathered behind shrubs that broke the wind. A buried dike throws a gentle ridge on the plot. A rusted fence line throws a sharper one. You learn to separate geology from junk, to love the way the instrument's tone rises over certain soils and quiets over others. The land becomes not just texture under boots, but a landscape of invisible pushes and pulls. There's beauty in the numbers. Remnant magnetization vectors point to paleofields. A basalt cap tells you which way north was when lava froze. In places, adjacent flows with different ages point different ways, a stack of magnetic timestamps. On the flats, a thin iron-cemented layer biases a compass by 2 degrees. 2 kilometers away, it does nothing at all. The zone's magnetism isn't a wall. It's punctuation, commas and italics in Earth's long sentence. If the ground is noisy enough, you can lose your way. If your senses lean on a single needle, you can make a poor call. But could that noise bend a missile's path? That question needs a different room, one with flight dynamics scribbled on a board, with inertial sensors humming, with wind profiles that don't care what the dirt thinks. We've walked the bones. Now we look up to the machine that arrived here by accident and ask what, if anything, down below could have whispered to it at all. Could magnetism crash a missile? To even ask that, you have to open the Athena and lay out its nerves. The guidance stack in that era centered on an inertial measurement unit. Spinning gyros or floated rate sensors paired with accelerometers, all bolted to a stable platform. The platform watched changes in rotation and acceleration, integrated them to estimate attitude and velocity, and told the guidance computer where the missile thought it was. Ground-based radar tracked the vehicle from White Sands, compared truth to estimate, and sent command updates by radio when needed. No one strapped a Boy Scout compass in the nose and called it guidance. Inertial wins because it's self-contained. It doesn't care if the sky is noisy or the ground is iron. But inertial drifts, small bias errors in gyros, fractions of a degree per hour, grow into big headaches if left alone. Accelerometers pick up gravity and motion, but tiny misalignments turn into wrong integrals. So range has layered aids, radar data to correct the estimate, radio commands to nudge the flight plan, destruct receivers to end it all if it wandered where it shouldn't. The chain wasn't fragile, but it had links. Now bring in the known villains. Wind shear is a quiet thief. A high-altitude crosswind you didn't model pushes the vehicle sideways. Guidance corrects, but with lag. Software limits harden those corrections to keep from oversteering. The result can be a gentle compounding offset. Sensor drift does the same job from inside. A gyro position error of a few thousandths, a scale factor slightly off, a calibration that warmed out a speck under ascent heat, each is tiny, together enough to walk the trajectory across a border on a long flight. What about electromagnetic interference? It can bite, but you have to be precise about the teeth. A strong external field near sensitive wiring can couple noise into a receiver or a sensor amplifier. Arcing from onboard systems can self-jam. Lightning can stun electronics. Magnetic fields, though, fall off fast with distance. The field from a vein of magnetite 100 meters below a rocket climbing through the upper troposphere is small compared to Earth's main field and vanishingly small at the sensor scale. Even on the pad, launch vehicles get demagnetized and surveyed to minimize hard ion effects. In flight, the guidance box sits in a controlled electromagnetic cage. Could a local anomaly twist a magnetometer? Sure, but missiles didn't rely on magnetic heading for guidance the way a small boat might. If a magnetometer was present, it would be used as a light touch aid for course attitude, heavily filtered, weighted behind gyros and accelerometers, and often ignored once the vehicle left the ground truth environment. That's by design. You don't hand critical control to a sensor vulnerable to every rock's opinion. Radio is more vulnerable, but the vulnerability doesn't point at magnetism. It points at geometry, propagation, and power. If the Athena slipped sooner than expected below a radar's best viewing angle, or if the radio command link hit a fade or a shadow, updates could be late or missed. A burst of noise, intermod, or a saturated receiver front end could garble a packet during the one window when the computer was willing to listen. In a high-speed profile, a lost update quickly becomes a lost path. Run history for guidance failures. You find wind misestimates, software bugs, inertial misalignments, structural flexing that introduced oscillations, sensor saturations, frozen servos, and plain old human input errors. You don't find magnetic anomalies in the dirt miles below causing an inertial system to hallucinate. In 1962, a Thor test swerved from wrong wind inputs. In 1980, a Titan experienced guidance issues tied to sensor behavior under vibration. The catalog of mishaps reads like a systems engineering textbook, not a geology field guide. Still, there are plausible EM channels worth testing. Could a ground-level magnetic gradient saturate a poorly shielded current sensor or a toroid in a power conditioner? Maybe on a bench with a box pressed to a magnet, not in a missile thousands of meters up. Could the command receiver take a hit from out-of-band interference reflected off terrain? Yes, and range is design link budgets with margin for that, but a fade during a correction window is enough. Could a lightning-like discharge from exhaust plumes at high altitude create RF that self-interfered? It happens with certain vehicles. That's why antenna placement and timing matter. The most likely chain here is boring in the way that breaks careers. A small inertial bias at launch meets an underestimated crosswind layer. The guidance loops compensate, but with unbounded authority. The ground radar picks up the divergence, but loses a clean track during a geometry change, low angle, multipath, or temporary dropout. A command update misses its slot. By the time the link clears, the solution needs a larger correction than the software will accept. The window closes. The vehicle flies a clean wrong arc into the desert. There's a human factor, too. Ranges operate with safety rules that limit when you can send commands and how aggressively you can correct. Those rules exist for good reason. They also create cases where, after 2 or 3 mischances, policy ties your hands. From outside the fence, that restraint looks like silence. Inside, it's the part that keeps people alive. What nobody at the time knew, standing under floodlights over scorched sand, was how easily a tidy legend would outcompete a messy system story. Magnetism is tactile. You can hold a compass and blame a rock. Software limits and gyro biases live in math. The Athena didn't listen to the dirt. It listened to itself, the wind, and a link that blinked at the wrong moment. Now, could a magnetically noisy ground ever matter to flight? Yes, indirectly. Pre-launch, if you align an inertial platform using magnetic heading in a hangar with poor calibration, you can bake in an error. That's why procedures call for star trackers, optical theodolites, or surveyed references. On vehicles without those, heading alignment errors have caused trouble. But out on a military range, those alignments use surveyed azimuths, not compasses. You don't trust a needle for $1 million shot. There's also the anecdote about compasses spinning during the cleanup. That's real enough in a few spots. It tempts a leap. If a compass spins here, maybe a missile couldn't keep its head. The leap ignores orders of magnitude. A 1-degree heading error at ignition matters. A 2-degree tug on a pocket needle beside a magnetite patch doesn't translate to a platform in a sealed box at altitude. The scale mismatch is the miss engine. Bring this back to the story you can feel. A countdown voice cracks. Telemetry turns ragged. The trace walks southeast. People reach for a reason they can touch the ground itself. But the failure chain runs through sensors, wind, timing, policy, and a guidance stack, built to be robust until it wasn't. Magnetism didn't crash the missile. The crash did something else. It poured fuel on a myth that already had tinder in the soil and iron in the stories. People, stories, and the birth of a legend. By dawn after the crash, the basin was telling two versions of itself. On one side of the tape, men counted rivets and angles. On the other, people counted beats of a story that had been building for years. The ranchers started. Nights can be bright here without a moon. Air so dry the stars feel close. They talk about evenings when the sky hummed, a low pressure you feel in your molars, long before a missile fell. One old hand says his burros refused a familiar trail near the flats, ears pinned, until he led them in a wide arc, swearing the air itself felt wrong. He doesn't own a radio. His proof is the way animals act. Prospectors add their own chorus. They're solitary by trade, but campfires pull stories out. One remembers August when his pocket watch gained 6 minutes by morning, as if it had sprinted while he slept. Another swears he lost an hour, then found it again when he reached a low ridge and his watch clicked back as if embarrassed. Time does elastic things when you're hot, a little dehydrated, with nothing but wind to set your pace. But in a story, a minute miscount becomes a lost hour that returns. A boy from a nearby ejido says the night of the crash, the air tasted metallic and his father's radio went to a hiss that felt too complete to be static. They banged the set. It returned with a station from far away speaking in a town accent they'd never heard. Later, a reporter writes that the zone blocks all signals. The boy remembers the strange voice. Both are true in the narrow way memories are, a detail that became a headline. Reporters arrive with angles already sketched. A headline needs contrast and stakes. Radio silence sits well against floodlights. A place with no voice full of people trying to speak in the hand, Mike's reads like a parable. One journalist quotes a scientist accurately about patchy anomalies and then leads with a subhead that promises the Bermuda Triangle of the desert. That phrase sticks. It's portable. It's wrong in a way that pays the bills. Authors follow with paperback covers that glow purple and green. They mix legitimate geophysics with anecdotes and blur method with mood. They quote locals and add ellipses that stretch sentences into suspense. A mining survey map turns into a forbidden zone diagram by labeling convenience. The funhouse mirrors multiply. The more the zone is a character, the less it's a place. The effect is psychological as much as editorial. Once a pattern is suggested, our brains fill gaps to protect the pattern. Government secrecy plays its supporting role without trying. The recovery needed rules, permits, escorts, logs, sealed containers. But filters that keep a mission clean become shadows to the public. A checkpoint to keep trucks from bogging down in an arroyo reads like a barrier to truth. A tarp load to protect sensitive materials reads like a crate that hides something unspeakable. People watch how officials stare at the ground, how they answer what they can and ignore what they can't, and the silence fills with speculation. Logistics becomes theater when the stage is already primed. The economy notices. By the following season, a roadside stand adds Zona del Silencio to its hand-painted sign. Cold sodas become colder if they're served near a mystery. Someone sells keychains with tiny compasses. A good day is when one wobbles enough to make a customer grin. A modest museum collects meteorites, rusty springs from an unidentified machine, and photos of floodlit nights. Tours develop an old pickup, a knowledgeable cousin, a loop past flats, a hill with a view, a pause to kill the engine and listen. The silence is real if you expect it. Locals embrace and resist in equal measure. A rancher rents his spare room to visitors who want to hunt for stones. He tells them straight, heavy rocks are easier to find after wind. He also tells them about the night his grandmother said clock stopped, because she did say it, and it makes their eyes widen, and widening buys feed. A school teacher builds a unit around magnetism, shows students how a compass responds to a magnetite sample from a nearby outcrop, then reminds them not to believe every headline. In the same week, she welcomes a TV crew and poses a class under a sign that says Zona del Silencio. Everyone learns to hold two truths. The story feeds the town, and the facts feed the mind. Memory bends to fit need. Spend 6 hours off-grid, and your sense of time goes strange. Without pings from towers or the march of emails, you're left with light and task. Shadows tell you where you are in a day. When the wind stills and the insects hush, your brain panics a little because silence can feel like being forgotten. That panic labels itself the zone did it. Years later, all you remember is the label. A humming air becomes an omen when a pressure front rolls in. A stalled radio becomes a curse when the battery was just tired. The feeling is real, the cause. You added to fit the story your group already believes. Tourism brands the desert as much as geology does. A restaurant renames a dish Silencio peppers arranged like a compass rose. A mural shows a compass needle bent toward a star. A festival invites ham radio operators to chase skip at dusk and stamp QSL cards with his own logo. Some old-timers shake their heads, say it used to be quieter, and mean both the airwaves and the town. Others say it's good to be seen. There's always the friend of a friend tale. A cousin's cousin saw soldiers chase a glowing ball across a flat. A truck died for exactly 9 minutes while an unseen hum grew and shrank. A photographer's drone lost control, then returned on its own with footage of nothing but sky. If you press, details evaporate. If you listen, the emotion remains, the desert making people feel small and watched and unmoored, a sensation we call supernatural when we can't place it. Then there are the near misses that sound like proof until you add the missing pieces. A reporter's compass spins on camera near a steel fence post. A tour guide's radio dies next to a salt sink. A prospector's watch gains time while baking on a rock in noon heat. Each has an explanation. Each carries better on a bus if you leave the explanation out. The tension isn't malicious. It's human. We want a pattern as neat as a logo. The legend organizes itself into a triangle. Missiles, magnets, meteorites. It's tidy enough to feel inevitable. A crash validates the whispers. Iron in the ground makes tools misbehave. Iron from the sky adds romance. Tie them with a line and you get a place that deserves capital letters. Untie them and you still get a place worth visiting, just with responsibilities attached. Don't fake the data. Don't flatten the people into props. Government after-action memos never mention magic. They talk procurement, communications, corrections to procedures. None of that keeps a teenager from painting Silencio on a board and nailing it to a mesquite post. None of it stops a writer from describing an otherwise ordinary dead zone in radio coverage as a forbidden circle. The boring truth and the thrilling story live side by side. In time, the town learns to harvest both. Strip the story to physics. What still stands? The basin has patchy magnetic anomalies you can measure. Radios fail into rain shadows and overconductive ground. Meteorites are easier to find where the land preserves them and people search. The hum you sometimes hear is wind trapped in arroyos, generator drones, blood in your ears. The awe when the stars come on is not a trick. It's earned, and it's enough without gilding, which is why the legend endures. It lets people point to the same horizon and see different things, a failure chain, a geologic quilt, a marketable mystery, a childhood memory, an excuse to stand still and listen. The Zone of Silence isn't a single event or a single claim. It's a community of stories draped over a piece of ground that rewards attention. Now, if we peel back the layers and hold only what measurement can defend, what do we keep, and what questions stay open? The science that survives the smoke. Start with what measurement doesn't argue about. This basin holds patchy magnetic anomalies, low in amplitude, tight in gradient. Stand over certain gravels and encompass biases by a degree or two. Walk 20 steps and it eases. A flux gate on a pole sketches small wiggles over basalt caps and iron-cemented layers. None of that little satellites. It just nudges simple needles and cheap sensors in places you can learn to spot. Radios hiccup too, but not everywhere and not all at once. Terrain carves shadows in VHF and UHF. Salt flats drink power on some days, reflected on others. HF opens after dark and closes at noon. Field logs show intermittent trouble that tracks with ground geometry and the sky's mood. Intermittent is the word that matters. The legend prefers absolute. Claims of perfect silence, the dome where nothing works collapse under cross-checks. A cruise handheld dies on the playa, while a farm truck's VHF, with a better antenna and ground plane, keeps talking. A tourist AM fades, but a ham's 20-meter rig lights up with distant stations. Put 3 radios in 3 hands and tell them to walk. Somebody will always hear something. The desert isn't a Faraday cage. It's a landscape with bad corners. Compasses spinning everywhere is another overreach. Spinning happens, but it's usually a local trick. A steel post, a buried fence wire, a magnetite-rich patch, or a damp needle that overshoots on a steep gradient. Serious surveys find gentle deviations across much of the basin and sharper brief ones over specific materials. Aviation instruments don't report chaos at altitude because the anomalies smear out with distance and modern systems fuse data that mutes local noise. A pocket compass is the drama queen in this cast. Meteorites fill glass cases in pockets, but dense. Finds don't mean a magnet in the sky. Preservation is king here. Aridity slows rust. Wind swords heavy from light, and flat ground makes seeing easy. Searcher bias finishes the picture. People walk where trucks can drive and where rumors point, so clusters bloom along paths. That doesn't make the irons less wondrous, just less exclusive. The zone's ground is generous to meteorite hunters, not uniquely favored by heaven. Radiation deserves clear numbers. Surveys with calibrated counters show background to mildly elevated levels in spots, thanks to natural potassium, thorium, and trace uranium in certain tuffs and sands. Elevated means ticks above average, not hazard. You won't cook electronics with gamma rays here, and your Geigers chatter near a heavy mineral lens is a geology lesson, not an omen. Tales of forbidden radiation zones survive because a meter sound is persuasive. So are facts. Dose rates sit in normal ranges for deserts like this. So what actually stands when we scrape off the showmanship? A quilt of geologic sources, magnetite in lags, hematite-stained beds, basaltites with remnants, producing local magnetic textures you can measure. A radio environment that shifts with topography, soil conductivity, and ionospheric cycles, creating pockets of silence and corridors of reach. A landscape that preserves iron from the sky and lets people find it with patience and good coils. Enough to keep a scientist busy and a storyteller honest, and to give the audience that earned aha without the gimmicks. What doesn't stand are the clean lines and sweeping borders. There is no triangle on the ground that flips a switch. No milepost where watches fail as a rule. No single dune where compasses obey no law. The map of anomalies is blurry by nature and detail. It changes over meters, not counties. Radio coverage maps draw in pencil, not ink, and they depend on where you stand and where you point. The allure of neat edges is human. The basin resists it. Open questions remain, and they're technical, not mystical. Fine-scale magnetic mapping across the basin is incomplete. Many transects exist, but dense, uniform grids could clarify how gradients play with hand-bearing errors. Seasonal changes in RF behavior over salt flats deserve long-term monitoring. Pair soil moisture, conductivity, and field strength by band to watch patterns stretch and shrink with rain and heat. A catalog of meteorite finds with rigorous coordinates and compositional data would separate true clustering from the path bias we suspect. The work is slow. The desert rewards slow. There's also the interface between folklore and measurement. How do we document subjective experiences, time feeling wrong, a humming air, without dismissing them or letting them dictate physics? One approach: co-locate physiological sensors with environmental instruments, track heart rate, hydration, and temperature while logging RF spectra and magnetic field. Find out when our bodies make mist because they're stressed and when the environment contributes. The result won't be a headline, but it will be honest. Meanwhile, there's wonder here that doesn't need ghosts. Magnetite grains, barely visible, add up to a nudge you can feel with a child's compass. A nighttime ionosphere, invisible, folds a stranger's voice into a ranch house. An iron heart from space waits a decade under dust for the right boot and the right coil. The wind writes the same tune over and over, and the radio dies in its lee until you climb a little. These are small magics that survive scrutiny. The missile crash fits this pattern too, once we strip the myth. It didn't prove a supernatural silence. It did show how a noisy environment, literal and cultural, can amplify a mystery. Telemetry dropped in a moment when geometry and propagation conspired. Cleanup under lights made the desert look staged. Compasses and radios misbehaved just enough to keep cameras rolling. The hard explanations, wind profiles, sensor tolerances, policy timing, are less cinematic, more real. If you want a test you can run, bring 3 tools: a good compass, a handheld VHF UHF with swappable antennas, and a magnetometer app tied to a calibrated sensor. Mark a line across a playa to a scrubby Bajada. Log heading bias every 10 meters. Switch antennas and note where the voice fades and returns. Watch the magnetic field in nanoteslas climb and fall over dark streaks. You'll walk the edge between story and science and find it's not a cliff, it's a slope. Crucially, the zone's reputation isn't a mistake. It's a translation. People encounter phenomena at the limit of their gear and frame them with the language they had. Scientists arrived with different words and found many of the same things, then measured them. Where the two vocabularies overlap, patchy magnetism, fickle radios, iron in the soil, the legend has a backbone. Where they don't, total silence, universal compass, chaos, we can let those lines fade without losing the plot. So we keep what's supported: patchy magnetic anomalies, intermittent radio trouble tied to terrain and soil, meteorite finds shaped by preservation and effort, radiation at background to mildly elevated levels. We discard the tidy triangle and the absolute claims. We keep the questions that ask for better maps and longer logs, and we keep the sense of scale, a desert that edits our tools, not erases them. Meanwhile, the awe remains, earned, repeatable, and enough. Micro stories from the field. The geologist set his tin mug on a tailgate and the coffee steam drifted sideways, thin as a thread. His magnetometer chirped once, then screamed like a smoke alarm. He looked down. A dark streak of gravel, flecked with black grains, cut across the pale crust. He took 3 steps and the tone fell off a cliff. He walked back and forth, the instrument's voice rising and fading as if the ground were breathing. He laughed at himself, then flagged the line with pink tape and wrote one note, noisy as hell, sharp gradient, lagged behind shrubs. He came back after lunch, the air had warmed, the instrument drift settled, and the same line sang more softly, a choir instead of a siren. His coffee was cold, but the map in his notebook had a new scar, a little proof that what people describe as a curse is really a pattern you have to earn. A ham operator with boots still new at the heel chased a rumor up a low ridge. He'd been told there was a sweet spot where voices ride the sky. He carried a stubby handheld and a longer whip in his pack. At the top, he swapped the rubber duck for the whip, clipped a counterpoise wire to his belt, and called. Nothing. He turned 10 degrees, called again, and a voice from 3 states away answered like an old friend. He stood still, afraid to break it. They traded names, then signal reports, then weather. When the breeze freshened, the voice faded, then returned stronger off a new angle. He slid half a meter to the left, and the path cleared. He stayed until the sun tipped and his own shadow made a little antenna. On his hike down, the radio died in a wash. Up on the next shoulder, it came alive as if it remembered him. He wrote later that the ridge taught him more than any manual. Height plus angle plus patience beats wattage. On a ranch west of the flats, a man who didn't trust batteries timed chores by shadows. His watch had a cracked face and a habit of blinking out when afternoons cooked the strap. He'd set it by a radio at dawn, then lose track by noon, so he learned the tempo of light on his yard. When the water tank's shadow touched the mesquite, it was time to turn the valve. When the corral's post shadow slipped past a rock, it was time to bring the goats in. One day, a visiting cousin laughed and showed him a phone app with a stopwatch. The man shrugged and held up his hands, palms dusty. "This is the only app that doesn't run out," he said. "This is the only app that doesn't run out," he said. Later, the phone died in a patch where the cell bars always lied. The cousin borrowed the shadow and said nothing else. A meteorite hunter moved like a heron, stepping, pausing, listening to the coil. His detector chattered low over magnetite-rich sand, a soft bed of static. He lifted the coil a little, slowed, and the chatter clarified to a single, round tone, the bell. He knelt and scraped with a screwdriver, exposing a corner of something dark and dense. 10 minutes of patient prying freed a palm-sized iron with thumbprints in its skin. He rubbed a magnet across it and felt it tug back with a personality. Later, he dug a dozen more holes that held nothing or held a rusted nail or a horseshoe. He didn't curse the false alarms. The ground here talks and lies until it tells the truth, and the truth weighs more than you expect. He kept the iron in his pocket for a week, just to feel the pull when he reached for change. A student crew, first time out with compasses that still smelled like the store, walked the line across a playa marked by their professor's stakes. At the first flag, every needle agreed. At the second, one needle drifted and its owner frowned. By the third, two disagreed with the rest. The professor had them stop. "Take 10, he said, and handed out biscuits. Then he had them walk 200 meters on the brushy ground and take bearings again. The needles settled into harmony. Back at the stakes, the drift returned for the same two compasses. He opened them. One had a tiny metal shaving stuck near the capsule. The other had a bubble the size of a sesame seed. They learned 2 lessons in a minute. The ground can tug and soak in your own junk. The professor made them plot both sets of data anyway, then contrast them with a sun compass at noon. The lines didn't match perfectly. They never do. They were good enough to find the truck. Another morning, a film crew set up a wireless mic and watched the levels dive whenever the host took 2 steps toward the salt. The audio tech frowned, swapped frequencies, watched the graph dance, then walked a slow square around the host. He found a corner where it worked and marked it by pressing his heel into the crust. The host never knew why he had to stay in that box. Later, the crew told a bar full of people that the zone killed their gear. The tech told his notebook it was a multipath fade from a hard-pan mirror, solved by moving a meter. Both stories were true in the way that kept everyone fed. A prospector swears he heard the air hum at sunset, a low tone. That grew until the hairs on his arm stood. He walked toward the sound and found nothing but a juniper full of bees warming themselves for the night. He laughed, then kept the story anyway, because the feeling was real and the joke was on him. His friend tells a different version at the cantina, skips the bees, adds a light in the distance. The room leans in. The next day, the prospector shakes his head and buys the friend a beer. A surveyor working a fence line watched his prism pole pull to the right as if someone grabbed it. He set it down, stepped back, and noticed the pole's bottom had stuck to a lump of black rock like a weak magnet. He moved the base a hand's breadth and the pole vanished. He marked the fence a meter off the planned line to miss a buried coil of wire that would have rusted itself into trouble. He told the landowner, who nodded and said, "That's where my grandfather dumped a broken harrow." The surveyor added a note to his map. "Trust measurements, ask elders." On a cold night, a graduate student with too many tabs open in her brain lay on a cot and listened to HF hiss. A voice rose and fell 3 times, then clarified into a fisherman off the Baja coast. They traded signal reports. He mentioned a breeze she couldn't feel. She mentioned stars he couldn't see for haze. They both laughed at the idea of meeting. When the band closed, the silence felt earned, not ominous. She wrote in her log that the ionosphere had been generous. In the margin she wrote, "Don't forget to say that out loud when people ask what the zone does." By the end of a week, the notebook pages held tiny dramas, a compass that lied near a fence, a radio that failed in a wash and sang on a ridge, a meter that shrieked over a gravel streak, a watch that blinked out in a shadow that kept time. None of it needed miracles. All of it felt like one, the way small, repeatable surprises do when you're far from the noise. The zone didn't silence anything. It's spoken in short sentences, and if you listened, it told you what kind of place it is. Meaning, pattern, and the allure of edges. Edge cases hook us because they promise shortcuts to understanding. The zone feels like an edge. Technology falters, rocks pull needles, a rocket misses. Our brains reward anomalies with attention. They feel like doorways. Stand in that basin and every small misfire whispers that the world has a secret. The secret here is smaller and better. The ordinary rules stack until they look uncanny. Neat stories are the trap. Missiles, magnets, meteorites, tie them together and you get a triangle too tidy to resist. A crash crowns a legend. Needles bend where iron hides. The sky drops stones right where compasses lie. That pattern is satisfying because it arranges noise into a symbol. But symbols clip away context. They flatten time. They swap hard-earned variation for clean borders. The human angle makes the pattern more convincing. A rancher's wristwatch skips. A mic dies on cue. A compass jerks next to a dark streak of gravel. Each moment is true in its frame. Stitch them, and it reads like orchestration, as if the desert chose to misbehave. What actually happened is harder to market. Granular magnetism, fickle skip, multipath, cheap sensors, hot batteries, tired eyes. A legend that sells prefers verbs like haunted over verbs like absorbed and refracted. Here's the risk. When a myth gets too neat, it starts to push out real awe. The awe here lives in specificities. Magnetite grains and lag gravels biasing a needle by a breath. A night ionosphere lowering in layers like a theater curtain. An iron from the asteroid belt resting under dust until a coil sings. Those don't need a triangle. They names, maps, and time. There's responsibility too. Legends draw visitors and put money in pockets. They also attract grifters and drown nuance. If you're going to trade on a place's mystery, you owe it accuracy. That means saying intermittent where a headline demands total. It means showing the meter in the soil, not just a reaction. It means reminding people that the missile's failure chain lives in engineering memos, not in the ground's magnetic opinion. We also owe the community its complexity. The zone is not just a stage for outsiders. It's ranch work, school schedules, water hauled, fences mended, a clinic run by a nurse who knows everybody's dogs. Turning a living place into a symbol steals from people who live with the wind when the camera trucks leave. The better story lets them speak in their own tense and keeps their practical knowledge at the center. How to read a ridgeline, where radios work, when not to trust an afternoon watch. So what is the meaning that survives the debunking? Pattern without borders. A basin whose geology writes faint magnetic notes into any instrument close enough to hear. A radio sky that breathes with the sun and terrain. A cultural memory that stitches glitches into folklore because that's how we remember when we talk. About the zone, we're talking about how humans meet uncertainty with narrative, then refine that narrative with measurement. It's a feedback loop, not a duel. We keep the but, therefore rhythm honest. The missile strayed, therefore recovery convoys arrived at night, therefore secrecy read as cover, therefore the name stuck. Radios faded, therefore people listened harder. Therefore silence felt heavy, therefore hams logged the skips. In each case, the next beat is a response that pulls us forward. The loop only breaks when we accept a final answer too soon. Wonder is safer when it's precise. The desert gives repeatable moments that feel like magic until you learn their rules, and then feel like a new kind of magic because you can call them. Walk to the edge of a salt flat and watch your handheld bars drop. Then step back to brush and watch them rise. Hold the compass over ironstone and see the needle hesitate. Call at dusk and hear a stranger cross a continent. Each is a teachable trick. String them and you get a language and a payoff that travels well in clips. And the language travels. There are other quiet places and magnetic oddities. In Nevada, dry pliers swallow VHF the same way. In the Kola Peninsula, anomalies punch harder and make surveyors sweat. The Australian outback preserves irons in lonely paddocks. None of these need triangles, only good boots and calibrated gear. The zone is part of that family. Edge cases by geography, not by metaphysics. We should also admit why the neat story keeps returning. It's efficient. It's social. Telling someone the zone kills radios moves a crowd faster than multipath fading plus conductive ground plus topography. Entertainment compresses for time. Science expands for detail. The ethical move is to compress with care, trim without lying, show the meter at least once, let a local voice frame a scene, and resist adding a glow where there is none. Scale is the final teacher. A needle in your hand lives at the meter scale, a walkie at the swale scale, a missile at the 100-kilometer scale. Confusing those scales bursts myths. Respecting them solves problems. The same patchy magnetism that nudges your compass is invisible to a guidance platform that never asks the ground for direction. The same salt crust that eats a handheld's wattage won't hush skywave at dusk. Knowing which tool belongs to which scale is how you keep from giving the desert powers it never claimed. So the allure of edges isn't a mistake. It's a map. Edges pull our gaze to transitions where systems reveal themselves. The zone is a set of transitions, rock to salt, ridge to wash, day to night, story to measurement. If we stand on those lines with both curiosity and restraint, we get the best of it. The myth shrinks to fit the facts. The facts stay large enough to move you. One last thread, humility. The desert has more patience than we do. It will keep its gradients and its preserved irons and its tricky air long after our cameras age out. Our job is to leave better maps and better stories than we found, so the next person can feel the same lift when a voice arrives from far away or a needle quivers over a dark streak and know both the rule and the romance. Then the zone stops being a place where certainty goes to die and becomes a place where knowledge feels earned. Resolution and broader meaning. The crash didn't conjure the zone. It exposed how quickly we bless noise with meaning when the desert edits our tools. Our here is specific: iron in the soil, salt that drinks signals, a sky that returns voices and sometimes stones. If you want more true stories where measured reality outlives the legend, subscribe and stick with us. Watch the next dive into Earth's strangest magnetic frontiers, places where compasses tug, radios fade, and the reasons are better than myths.